Hi, good afternoon. Thanks for taking time out of this beautiful Sunday to sit and learn about Beaker. I think it's about the most exciting thing I've worked on in almost a decade, and I hope that by the end we'll convince you that it's something you should at least try. So, I'm Matt Greenwood, by the way. I guess I should have. This is Scott. I'm just the front man. Scott does all the work, and he's going to demo Beaker for you later. So, in order to explain to you what Beaker actually is, I have to tell you a little bit of a story. Tell you a little bit about what 2 Sigma is and why Beaker became incredibly important for us. So, very briefly, you probably haven't heard of 2 Sigma. 2 Sigma Investments is a large investment manager situated about 20 blocks south of here. We're a good number of 100 people who work in investment management. And the easiest metaphor for everyone in the room is to say, as Amazon is to retail, so 2 Sigma is to investment management. We're fundamentally a technology company with tens, if not hundreds, of engineers and modelers whose goal it is to figure out the best thing that we should invest for our customers across the globe in order to give them a return that we think they're entitled to and we can get better than anyone else. Or as I like to say to my mother, our job is to forecast the future. And that's what we do at 2 Sigma. Now, 2 Sigma is really divided in many ways into modelers and into engineers. And the modeler's goal is simply to take something that they understand from an idea that they've heard somewhere from a blog, maybe from a paper, and turn that into reality. And so very frequently, the modeler will start off with this. Okay, so for about 10 years of my life as a mathematician, this is what I looked at every morning. Every evening, most of this was in the garbage. If I was lucky, I got 1 or 2 pages that I could take home. But really, that's hard. I think this looks good for about 20 seconds. But really, we need something more structured. And so this is probably a much better way of figuring out how stuff works. It's not surprising that this is the ubiquitous lab notebook. Those squares on the page just have this way of jumping out of you. And we use lab notebooks across the globe for data science and for science in general to do a huge amount of things. So here are some examples of lab notebooks that you'll see. And you'll see that actually the use of lab notebooks is quite huge. There's a fair amount of text that's written on some of these notebooks. Some ideas, maybe some things that are important that you'll circle with a highlight. There's a lot of formatting that goes on, a lot of mathematical formatting you'll see down in the lower right-hand side. Some beautiful multimedia on the left-hand side. And maybe some notes about what you need to take home for dinner that evening, or other ideas that you might come back to in many months. And in many ways, what we wanted to do in technology is to be able to give our modelers and data scientists this kind of rich experience that they would have on a piece of pen and paper, with a piece of pen and paper, but actually in a notebook. And so when we were thinking about 10 years ago, I've been at the company for over a decade, so about 10 years ago when we were trying to understand what we could give our modelers, many of them had come from a background where lots of scripts were written in Awk, in Perl, maybe increasing numbers then in Python, far less than today. A lot of the stuff that we use regularly in Python today just was a gleam in people's eyes back then. And we sat and thought long and hard over the years about how we could find a paradigm that would work both for our modelers and for us. And I mean this in 2 different ways. When you have a company that you expect to grow and you want to be really good, you have to think very, very forward. You have to think, what am I going to need, not now, but maybe in 5 years or in 10 years' time? And we were lucky or unlucky to be kind of on the cusp as Perl was dying and Python was coming up the ranks. And we understood that modeling languages, just like all programming languages, come and go. And therefore, what we wanted to do is provide an infrastructure that would allow these languages to naturally come along and dominate for a while and then maybe drop off. And so it was very important to us to build an environment that allowed us to do so. The other thing that I came to this was a quote that I'd heard many, many years ago, attributed to Charles V, the Holy Emperor of Rome, who said that I speak Spanish to God, French to men, Italian to women, and English to my horse. Now, I will admit, we English are a little bit horsey from time to time, but I think that there was something much, much deeper in that quote that I'm going to appropriate from real languages to modeling languages. And that is, he was attempting to point out that every language that exists on this earth is really good at a couple of things. Maybe it's talking to God and that was Spanish, or maybe Italian is actually the language of love. But every language can do one thing really uniquely. And that was the other thing that we came to this notebook with. We understood that there would be ways to write in this notebook that you wouldn't want to go back and recreate. Not every language can do everything the same way as every other language. And we want to be able to preserve the best out of every language so that indeed the whole will be far, far greater than some of the parts, or the other way around. I apologize. So we came up with Beaker. Beaker is the data scientist laboratory. It's a notebook-style development environment for working interactively with complex data sets. Or if you like, this is the IDE for data scientists. In addition to being a general IDE, it has a polyglot architecture that allows you to switch between languages and to add new ones with ease. And so what we did is we took all of those ideas that we saw in notebooks over the years, and we tried to implement as many of them as we could, as easily as we could, in our notebook. So this is some screenshots of what we were able to do. And what you'll see is that we have appropriated some of the typesetting in the top right-hand side. We have LaTeX for typesetting, or down below some HTML or some Markdown. There are some beautiful visualizations and some standard rendering of tables. And this follows the standard notebook paradigm that we all know and love from Mathematica from many years ago, input cells that are executed to provide output cells. So we've one-upped the standard notebook by allowing you to actually execute code that you write into the notebook, akin to just about every other notebook on the market today. But as I said, Beaker is polyglot, and Beaker is polyglot out of the box. We support the following languages in the current open source distribution: Python, R, Julia, JavaScript, Groovy, HTML5, Node.js, LaTeX, Ruby, and a couple of others that aren't actually on here. And you'll see that those roughly split into two or maybe three different areas. Firstly, there are ways in which you want to express yourself, like LaTeX or Markdown or HTML, so that you can write what you want to write. Because at the end of the day, when you create something in the notebook, you don't create it for yourself. You're creating it to give to other people. And you can give them, 3,000 lines of code, or you can give them a notebook that actually looks beautiful and speaks to them in their language. And then there is the language of data science itself: Python, R, Julia is a newcomer and fast growing. MATLAB might be there, or Octave, Groovy, Ruby. These are all different languages that you can use to program in order to pull out the insights that you want from your data set. And finally, there are things like HTML5 and JavaScript that allow you to manipulate the results of your data science into something that other people can play with. Some beautiful visualizations, some graphics that are simply not available or less available because maybe your favorite scientific language isn't quite your favorite visualization language. And so down below, there's a classic example of what we mean. So you might have some code that you've used for a long time in Python that will allow you to go out to websites, to pull in some data, to manipulate it, to parse it. And you happen to be learning R right now because that might be trendy to do. It might be something that you want to do. Well, you don't need to learn how to do all of that in R. You've got that already baked in Python, and you can focus on understanding in R the things that you want to do with R. So you might want to do some plotting or some distributions. And then finally, you might want to display that in a rich format, something like D3 or some other plotting library. And indeed, in Beaker out of the box, we have our own quite beautiful plotting library that is contained in the distribution. So just to dive a little bit into auto-translation before I turn over to Scott to do some demos and dive even deeper, the key piece of technology that allows Beaker to really be polyglot is the ability to transfer data from one cell to another. So I have one Python cell, one JavaScript cell, and you see at the bottom what it actually looks like. We've taken care that where languages offer the opportunity to do kind of meta-programming, it looks quite natural in a language. So here, for example, at the bottom left, we are setting a Beaker variable to be x in the Python cell, and then using it subsequently in the JavaScript cell, again, with just beaker.x. The way that works, very briefly, is that every language simply renders the data that it needs to save to the notebook into a language-agnostic JSON blob that then can be read by any of the languages that we provide. And so in this way, you can pass data all the way through your notebook from any language to another. So let me turn over to Scott.
Thanks, Matt. So I'm going to review the architecture and just tell you a little bit about how Beaker works, and then I'm going to give you a live demo. So here's a pretty standard diagram. You can see the emphasis. We're using all the latest open source infrastructure. So like our server is implemented in Java with Jetty. Our client is implemented, it runs in the web browser. It uses the latest HTML5 features. It's based on Angular, which is for templating and data binding. It has a really nice sort of model view controller architecture, so it's easy to work in Beaker. And the languages that you can run in Beaker are implemented by these back-end servers. And so, and we use the standard native backends. So when you run R in Beaker or you run Python in Beaker, we're accessing the R or the Python that you already have installed on your computer. And in particular for Python, we actually use the IPython protocol, so that we're actually essentially, in that case, where Beaker is actually like a front end communicating with the IPython back end. Now, also on the server side, we use Nginx as a reverse proxy, and that makes all the servers appear as a single server to the client. That makes it easier to program, but it's also really useful for security, because that means the authentication and encryption can be done in one place, and that's really useful for sort of like institutions or sort of enterprises that want to work with Beaker. On the client side, I want to point out one part of the architecture in particular, which are the plugins. So Beaker does a lot of, the client side is implemented in JavaScript, and so it can do dynamic loading, and we have a plugin API for the data that's produced. And so the main ones that we already have are HTML, the plotting and charting, and another one is tables like spreadsheets. And you can add your own visualization plugins if you have your own way or a new way to visualize or interact with data, or if you just want to take your favorite library and sort of incorporate it. It's pretty easy to plug it in to Beaker. Another plugin API that is really important to Beaker is the one for evaluators. That is the one that sort of implements the glue that allows Beaker to speak each language. And that's also JavaScript, and it handles things like auto-completion and code highlighting, and it defines the protocol that the web browser uses to communicate with the back end that actually executes the code in that language. So now I'm going to switch over to the live demo. So here I've got let me zoom this a little more. So here I have Beaker running on my laptop, and this is a page in my, in my web browser. Let me just pop it back here so you can see it's just connected to a port running on the local host. And the first demo is to create a random network in Python and then visualize it with JavaScript and D3. And so here's some Python code. You can see, so this is the kind of, when I say graph, it's like the kind that has nodes and edges. We just generate a bunch of random connections, and then we assign the result to the Beaker object. And the Beaker object is the one that's shared among all the cells. And I'm also going to actually, at the very end, I'm going to return the beaker.graph so that we can see it. Oops. How'd that happen? So you can see the result is just an array of dictionaries. So we don't want to really look at it too much. We're going to move on to the HTML, which describes some styles. So we're just going to run that, and then some JavaScript. And in the JavaScript, you read out the Beaker object, the Beaker.graph, you read it into JavaScript. And then it's a bunch of sort of standard D3 code. And when you run that, you end up with a nice interactive sort of D3 visualization of the graph. So the next demo is of the interactive tables and charts. So here's some Python code that contacts Yahoo and reads out a data frame. And again, I'm going to assign it into the shared Beaker object and then just return it so that we can see the results of it. And I decided not to rely on the internet, so I have this one sort of I pre-ran this cell. And the output that you get is just a nice interactive table here, so you can click on the columns and sort them. You can do things like select all and copy, and then just paste it into Excel if you want to manipulate your data that way. But really, Excel is not my favorite way of interacting with data. I'm more of a, if you want to make a chart, like a standard time series plot, we have our own library for doing that. And that library works with any JSON, it uses a JSON data structure to specify how to turn the time series and how to visualize it. You can create JSON in any language, but we have a nice Groovy API that sort of is that makes it even easier. So I'm just going to use the Groovy version, and when you run that, you end up with a standard price chart. And what's nice about this is it's not just a PNG image; it's actually interactive. So you can look at with the mouse, you can sort of play with it and read values off. You can drag it and you can zoom it. And actually the nicest form of interaction is actually sharing. So let me show you that. If you go back up here, you can share with just one click, and you can share any cell, any section, or the whole notebook with just one click. And so again, I'm not going to rely on the internet right now. But if you were to click that, this page comes up, and it has the same graph on it. I'll just show you here. It gets uploaded to the sharing.beakernotebook.com, which is a website that actually connects to GitHub Gists, similar. And so anybody who has this URL, you can look at, and this is just a regular web page now. But what's really cool is that the interaction still works. So I can now, in the shared version, the data is still live. So now the next demo is about another feature of our plotting library is how it handles large data sets. So, having interaction where you can point at the line and sort of interact with the plot and drag it and zoom it, that's all very nice. But the problem with working with SVG and HTML5 like that is that when you have thousands of data points, your web browser starts to run more slowly and might even crash. So here's an example where I have two lines. They're just random walks. They have 10,000 data points each, and yet the interaction here is still at a really high frame rate. And that is possible because Beaker is automatically filtering the data, and so it's averaging the data points that would be too close together and reducing it to a single DOM element. But the downside of doing that, the upside of doing that is that your browser doesn't crash and you can interact with your data. The downside is that you've lost some information, and you might be seeing only the average instead of all the actual points. So to help ameliorate that problem, Beaker can replace just the line with the actual, say, a box or river representation. And so now we're seeing the average and the minimum and the maximum of each group of points that got filtered down to a single DOM element. And so now you can see we can zoom all the way out, we can see all the points, and we can zoom all the way in. And if you keep zooming and keep zooming, eventually you'll get to a point where it doesn't need to filter the data anymore. There, it just popped out. This is the raw data. And if we zoom out, you can see, and now we can mouse over, we can still see the min, max, and average. So that's Beaker's interactive plotting library and its level of detail feature. So the next demo I'm going to show you is something that might be especially good for this audience. So Beaker being polyglot, it allows it to speak multiple languages, and that includes, as a corollary, the languages of Python 2 and Python 3, which are effectively different languages. And with Beaker, you can actually run Python 2 and Python 3 in the same notebook and use auto-translate to communicate between them. So here's a quick example. I'm going to use the mechanize package, which has not been updated to work with Python 3. So, but I'm not going to, again, I'm not relying on the internet, so I can't run this cell. And you can see I neglected to run it in advance, though, to get the output here. Fortunately, because of the way this Beaker object is implemented, it's not just a way of communicating between the cells, but it actually is storing the data in the notebook. And so even though I'm not connected to the internet, you can see here when I ran this cell this morning, when I was connected to the internet, it was stored in this beaker.url text variable. So that's still defined. Now, oops, I got that weird problem. This is what happens when you run from master on a development project. Okay. So the result of reading from the mechanize library is just a long string, which is the text of the notebook. We don't really want to look at that. Instead, what we want to do is use now Python 3. So here you can see that this cell is in Python 3. Python 3 has better support for parsing Unicode and just working with strings in different languages, and web pages, in fact, have many languages on them. So this is kind of a toy. This is a toy parser, but I'm just going to make a histogram of the HTML tags on that web page. And so once again, the output is an array of objects, and we don't really want to look at that. Instead, I want to visualize it. So I'm going to run some HTML to define some styles, and I'm going to run some D3 code, boom, to create a nice little visualization of what's on that web page. Okay, so that's the end of the demos. And I'm going to switch back to PowerPoint. And the next, so that's what we have working today. So how about the future? There's a couple of things that we're thinking about and planning for. And in particular, collaborative editing is something that we're very interested in. So basically having multiple people working on the same notebook at the same time, like in Google Docs. We'd also like to allow you to reconnect to a running instance. So for example, to be able to start a cell evaluating and then close your laptop, go home, open your laptop, reconnect to the server, and then get the result of that execution. And a third thing we're looking at is improving auto-translation, basically improving the performance of it. So right now, auto-translation is really easy to implement, but the data has to be copied between your web browser, between the backends, and so it's could be faster. And so the solution to all three of these problems is the same. It's basically we want to move the sort of the main data model, where is the notebook stored, from your web browser into the server. And once the notebook is actually in the cloud and we have just a thin client where we're connecting to it, we can increase performance and add features like collaborative editing and disconnected evaluation. So in summary, Beaker is a data scientist's laboratory. It is open source. It is Polyglot. It's notebook-based. It has auto-translation to communicate between the different languages. It's easy to extend because it has a plugin architecture, and it's easy to use because it was designed with the latest tools for people working today. So you can get it from beakernotebook.com, and it's open source, so that you can get the source code on GitHub. We are really actively looking for collaborators. If you have your own language that you would like to add or your own visualization that you would like to see work in Beaker, please contact us. Or just, if you want to, use it to do your own data science, please download it and let us know what you think. Thank you very much.